Hello, everybody. Happy Friday. Congratulations. We made it through another week. I am so glad you're here joining us for another edition of our virtual math class. Y'all, I know this is a strange time, as I always say, but I am so glad that you're here joining us. I'm also looking up above me back there. I'm like, oh, dear goodness, I really do have to clean that back up. Looks a little tacky up there, but please don't judge me too much. I will have it fixed soon. Y'all, we are going to continue our work with decimals today. We had been adding decimals. Today we're going to start subtracting decimals. But before we begin with adding or subtracting decimals, we're going to start reviewing some place values. As you probably have started to see, there's a number behind me back there. I'm blocking the view of it. I am going to share it on my screen, and I'm going to ask you all a few questions about it. Now, you can say your answer out loud. You're at your home. I won't hear you. You can write your answer down, or you can just think it for each of these questions. But I will ask you each of these questions out loud, and I want you to think about your answer. You can say it out loud if you want, write it down, or just think it in your head. But here is our number. It is 7. Oops, sorry, wrong thing. There we go. 76.358. Now, I want to start by saying, hey, what number is in the tens place? What number is in the tens place? That's the 7, right? Okay. What number is in the thousandths place? Thousandths place. Yep, that's the 8. Absolutely. What place value is the 5 in? What place is the 5 in? Absolutely, that is the hundredths place. What about that 6? What place value is the 6 in? Absolutely, that is the ones place, which then means our 3 is in the tenths place. Awesome. Now we're going to start with 3 quick addition problems with some decimals. Oh, you can't quite see that if it goes behind my head there. There we go. 3 quick addition problems, adding up some decimals. Pause this here, solve those, and then jump back in with us once you've had those 3 problems solved. Awesome. Y'all, that first one, I know that one. Second one, I know that too. Third one, I know that. I hope you do too. That is just for you to review. If you have questions about it, definitely let me know. And now we are going to move from adding to subtracting some decimals. So, I am going to, before we begin that though, we are going to start with our problem of the day. All right, I'm going to try and do this well. Let me zoom in just a little bit more and a little bit more. There we go. All right, so this is our application problem today, the problem we are starting with. It says, at the 2012 London Olympics, Michael Phelps won the gold medal in the men's 100-meter butterfly. He swam the first 50 meters in 26 and 96 seconds, 96 hundredths of a second. The second 50 meters took him 25 and 39 hundredths of a second. What was his total time? I'm going to read that one more time since I messed that up pretty bad. It is kind of small on that screen, so I'm going to read it again. I'm going to get a little bit closer. It's going to be awkward. I'm sorry. There we go. At the 2012 London Olympics, Michael Phelps won the gold medal in the men's 100-meter butterfly. He swam the first 50 meters in 26 and 96 hundredths seconds. The second 50 meters took him 25 and 39 hundredths seconds. What was his total time? Y'all, there's some things you might not know in here. There's some things that are definitely really not important at all, so we're just going to get rid of all of those right now. So do we care where he swam this when we are solving our math problem? No. Were there Olympics in London in 2012? Yes, there were. Do we really care? Nope. We're going to get rid of all of that. Well, guess what? The gold medal's pretty good. Gold medal means you came in number 1, and so Michael Phelps really did win the gold medal. But again, we really don't care about that either. Guess what? He's a guy, so he swam in the men's. Y'all, he swam 100 meters. The butterfly is a type of swim. goes like kind of like a butterfly. You go in and out of the water. I'm not very good at it, so I will never do it unless they make me. So I will cross out butterfly, because guess what? We don't really care what he swam. So here we go. He swam the first 50 meters in 26.96 seconds. The second meters, guess what? I'm going to cross out he swam. First 50 meters, that's time. The second 50 meters, 25.39. And then it says, what was his total time? So we are now asking, what are we trying to find out? We are trying to find out his total time. All right. This is where I set you on your own to go ahead and try and solve this problem. Pause the video here. Try and solve this problem. Find out what Michael Phelps' total time was for the whole 100 meters. All right. Once you got this solved, come back together and we will talk about it. Awesome. So I bet that you knew that we had to take those two numbers and add them together. Why did we have to add them? Well, the question is asking us about the total time. And when we're talking about the total of something, that means we're going to take all the parts and add them together. Okay? So I am going to, real fast, did not think this through, grab a piece of paper, and then we will look at this together. So the first 50 meters was 26.96, 26 and 96 hundredths. The second 50 meters was 25.39, 25 and 39 hundredths. You told me that we had to add those together, so I'll put an addition sign there in the middle. Now, I remember when we were talking this week and last week about adding some decimals, we like to set them up vertically. That means up and down. So as we set up this problem vertically, we'll do 26 and 96 hundredths and 25 and 39 hundredths. Add those together. Now, we remember it is so incredibly important before we even start this problem. Oh no, we're running out of space. What happens if I zoom out? Yeah, that's really awkward. So now that we have our math problem, I'm going to get rid of all this crossing out. There we go. Awesome. And then we can focus on our math problem. So now that we have our math problem written vertically, we already, before we even begin to add it, we already know where our decimal place will go in our answer. Because when we are adding and subtracting decimals, our decimal place just gets all lined up right there. So the decimal place in the first number was between the 6 and the 9. The decimal place in the second number was between the 5 and the 3. So the decimal place in the answer will go right in that line as well. We know once we've got that decimal place in place, we're able to just add these up like we would whole numbers. Talked about the differences and similarities of adding decimals and adding whole numbers. One of those things is we just add following the standard algorithm. So I'll do that. 6 plus 9 is 15. We regroup our 1. 1 plus 9 plus 3 is 13. 1 plus 6 plus 5 is 12. And 1 plus 2 plus 2 is 5. So our answer is 52.35. 52 and 35 hundredths. Remember, because that 5 is in our hundredths place, we're going to read that number 35. 35 what? 35 hundredths. Because that 5 is in the hundredths place. Now, I remember it's also really important when we have a math problem like this, we need to label it. What are we going to label our answer? Well, what was the unit in the question? There was meters and there were seconds. If the question says what was his total time, meters is how we measure distance, how long something is. So if we're measuring time, we must be using seconds. This is how long it took Michael Phelps to swim 100 meters. Now, a meter is 3 inches longer than a yard. So they're about the same size. So if you want to picture how far 100 meters is, think of a football field. A football field is 100 yards, and a yard is close to a meter, so 100 meters is about the same length as a football field. In 52 seconds, 52 and 35 hundredths of a second. That is less than 1 minute, and we know that because A minute is 60 seconds. That is less than 1 minute. To swim the whole length of a football field. Oh my goodness, that is fast. But anyway, that is our answer. We added those two decimals, the first 50 meters and the second 50 meters, added them together to get our total time. Awesome. I love it. Now we are going to begin subtracting some decimals. All right. So we are subtracting 5/10 minus 3/10. I want you to think about how you'll solve that problem, then solve it using a place value chart or some dots, whatever you want. So what you may notice is since our units are the same, 5/10 and 3/10, since our units are the same, it is very similar to subtracting 5 minus 3, just the whole numbers. 5 minus 3. And we know that 5 minus 3 is 2. And then since our units are the same, we would have 2/10. 5 minus 3, 5/10 minus 3/10 is 2/10. Okay. Now we could draw that out in a chart as well. Our ones place is here, our decimal is here. Then we have our tenths place. And we would have 5 in the tenths column. And then we would take away 3, so we would cross out 3. And we are left with 2/10. Awesome. We could also do that with numbers. 5 minus 3 equals 2. 2 what? 2/10. Awesome. There we go. Y'all, our next one, we are going to do 7 ones, 5 thousandths, minus 2 ones, 3 thousandths. So 7 ones, 7 ones, 5 thousandths, minus 2 ones, 3 thousandths. And I have run out of space. I am so sorry there. Whew. I'll slide that up. Y'all, also, since we are doing this all together, please make sure you're writing down these math problems together. That would be awesome. Awesome, awesome. Thank you, thank you, thank you. And we are going to make another visual chart for this, especially because we have a jump in our place values. We're jumping from the ones place to the thousands place. We want to make sure we have our answer correctly. We got the ones place, our decimal place, the tenths place, the hundredths place, and the thousandths place. All right, our orange number that is our starting number says that there are 7 ones. 1, 2, 3, 4, 5, 6, 7, and 5 thousandths. 1, 2, 3, 4, 5. Okay, and then our blue number that we are taking away 2 ones and 3 thousandths. So we're going to take away 2 of these ones. We're going to take away 3 thousandths. Now we're going to ask ourselves, how many ones are left? Well, I can tell there are 1, 2, 3, 4, 5 ones left. Our decimal place always, always, always stays in the same place. And then there are 2 left in a thousandths column. But hold on. In order to get our answer in a digit form, we have to fill in these 2 empty place values. We can't just smush the 5 and the 2 together and say 5 and 2/10, 5.2, because that would not be right. We cannot just say 5.2. No, 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 no. Because we have 2 empty place values. And when a place value is empty, that's the same thing as saying there are 0 in it. So we would have 5 and 2 what? 2 thousandths. Because our 2 is in a thousandths place. We have 5 and 2 thousandths. All right, I like this. I like this so far. Y'all, let's do another one. And I'm going to write the problem up there. I'll label this one 1, This one 2. This one was 1. This one was 2. And we are going to do 9 ones, 5 hundredths, minus, sorry, my minus sign should be green there, minus 3 hundredths. Hundredths. All right, I'm going to draw it in a line here, and then we will do the same thing. I need 9 ones over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 5 in the hundredths column. Our decimal place is always in the same spot. And then we are going to cross out 3 in the hundredth spot because we're taking away these 3. Cross out that one, and that one. Now let's take a look at what is left. Nothing changed in our ones column, so we still have 9 ones. We did take away 3 from our hundredths column, so we're left with 2. And we need to fill in a 0 in our tenths place because there's nothing there. There wasn't anything to start with. We didn't add or take away any, so there's still a 0 in the tenths place. Awesome. Great job, y'all. I hope you got this. We are good to go. So, now we're going to have a number we have to regroup. We are going to do 8.3, which is 8 and 3 tenths. Woo! 3 tenths. 8 and 3 tenths minus 6 and 4 tenths. 6.4. And I did switch my colors up here to keep things interesting. I'm so sorry. I should have kept them in the same order every time. All right, so we have to make our chart as we have a number in the ones place and a number in the tenths place. We're going to start with our blue number at the front. We have 8 in the ones place. 1, 2, 3, 4, 5, 6, 7, 8, and then 3 in the tenths place. Now, we need to take away 4 in the tenths place, but hold up. There's only 3 to take away. We must first regroup one little dot from the ones place, and 1 dot in the ones place can become 10 dots in the tenths place. Okay, so that 1 dot I'm going to cross out in blue because we are regrouping it over here. We're going to add in 10 more dots. 5, 6, 7, 8, 9, 10. So now we have 13 dots in the tenths place. We are down to 7 dots in the ones place, but now we have enough in the tenths place to cross out 4. Now we're going to subtract 4 from the tenths place. 1, 2, 3, 4. And we're going to cross out 6 in the ones place. 1, 2, 3, 4, 5, 6. How many dots do we have left in the ones place? Absolutely, we just have 1 dot left. In the tenths place, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 dots left. And our decimal place always goes between the ones place and the tenths place. So our answer is 1.9, 1 and 9 tenths. Again, because our 9 is in the tenths column, we say 9 tenths. Okay. So I want us to now think about this with numbers instead of dots. Because I know that y'all could do 83 minus 64. And you could do that. You say, hold up, there's not enough to take 3 minus 4. I'm going to have to regroup 8. 8 becomes 7. We regroup that one into make the 13 in the ones place. 13 minus 4 is 9. 7 minus 6 is 1. Okay? Drop my blue pen there. It is incredibly, incredibly, incredibly similar with our decimals here. We are going to do 8 and 3/10. Just like when we were adding decimals, when we are subtracting decimals, we are going to line up our decimal place always, always, always. So our decimal place, I threw my highlighter, so I gotta go grab another one. I will get that after this video, I promise, but there we go. We always, always, always line up our decimal place, so our decimal place and our answer is going to be in the same line. We say, hey, we can't do 3 minus 4. We don't have enough. If I have $3, I can't give you 4. I gotta borrow some from my mother. So we can regroup our 8 here. 8 ones, make it 7 ones, and make this a 13/10. 13 minus 4 now we can do. 13 minus 4 is 9. And 7 minus 6 is 1. With the same answer. And it looks very similar to this answer over here. Just we have a decimal number. Okay. Now we're going to write down one more thing, and then I'm going to send you on your way. This is just like what we said when we were talking about adding decimals. When we subtract decimals, we must, have to, need to, every single time line up our decimal place. Decimal places. And please underline that word must. Underline that word line. Underline that word up. I'm going to highlight the word must line up. It is so important when we are adding and subtracting decimals. That decimal place has to be in a line every time, every time. Because if it's not in a line, it's not going to work out for us. Okay. Y'all, this is where we are going to pause today. We are going to pick up with some more subtracting of decimals on Monday. Y'all, as always, if you have any questions, just let me know. I love y'all. Y'all stay safe. Have an amazing weekend. And I can't wait to see you back here on Monday. Bye, y'all.